Suppose that there is some calculation or procedure that we wish to do again and again in different places in our code. One way would be to copy and paste it at all the locations in our code at which we wish to perform this operation. Now, first off, copying and pasting is very inefficient. That is, it would make our code very long. The second thing is that suppose we wish to change that operation a little bit and we want that change to occur everywhere. We would have to once again copy and paste that. Now, what happens if you miss one of those copy and pastes? And even if you don't miss, how much time would it take for you to do this again and again? This is why we have functions. Functions let us treat our entire big body of code as being composed of smaller and smaller pieces, and each piece can be analyzed independently and then integrated with the rest of the program. So because we can analyze each function independently, that simplifies things a lot. So it's like its own independent module. Right, so suppose we have a mathematical function f of x is equal to x square. So here the parameter is x and the value that is returned is x square. So we could think of this as a little box with one input and one output. The input is x and the output is x squared. So how do we implement this as a program? So now the first part of the concept of functions is the function definition. The function definition is where we define the internal structure of a function. So we have int square, or let's make this a bit more complex, float square, float n, float answer is equal to n squared, return answer. So there are many things over here. So first is this float. So this is the return type of the final answer that we are returning. So this return statement, whatever is the expression that follows the return statement, that is what will be considered to be the value as such of the function. So let's make this example here a little more complicated just to get the idea clear. Suppose we have some f of x. Y is equal to x square and then z is equal to 2 star y plus 1, and we say that f of x is equal to z. What this means is that the value of z is the return value for f of x. So basically, if you put this function with a proper value, what will replace that function is this answer over here, and this float over here is nothing but the data type of that answer. Now square over here is a name. The same rules of variable nomenclature apply. Now here this is a list of parameters. Unlike mathematical functions, we also have to list the type of each parameter. And these parameters are then used as internal variables, variables which are inside the function. So here I have defined a new variable answer as n square and return answer. So that is a function definition. Now let's see the different types of functions in terms of their return type. Now, a function need not always return something. There are actually two types of functions. There are void functions and non-void. So what happens with void functions is that there is no return statement. So this would be like having a box which has some input wires but no output wire. Now a non-void function will return exactly one value, and this value could be an int, a char, a float, and some other things. Right, now we have made this function, so let us try to use it. Let's say float x is equal to square of 5.01. Print this. So now you can see some warnings and some errors. That was completely expected. So first warning, implicit declaration of function square. Next, error, conflicting types for square. And it references the previous implicit declaration of square. So let's go back and see what has happened. So what you must understand about the way compilation works is that it goes from top to bottom. From the first line it starts and then it starts going downward. Then what happens over here is the compiler has no idea about the return type of the function, and it has no idea about what kind of arguments the function is supposed to accept. As a result, what the compiler does is that it assumes some things. It assumes these functions to have int return type. So how do we resolve this? One approach would be to take this function definition and place it above the main function. Now that's not very pretty. In fact, it is a standard practice to instead put a function declaration. Now this function declaration just provides us with the information about the function return type, the function name, and the types of the parameters in order. Not even the parameter names. For example, float, square, float. Now let's try this. Somebody please verify that value. It appears to be okay. Makes sense. So that worked. So that is the use of a function declaration. So I could put anything here within reason. Let's see what happens if I do that. The output remains unchanged. So this right here, whatever names you put in the function declaration for the parameters, those names, the parameter names in the function declaration, they have no meaning whatsoever. So what happened over here is fairly obvious if you recall what happened with functions. Whatever this value is that we pass, that gets plugged in over here. So n is assigned the value 5.1, and that value of 5.1 is again substituted over here and evaluated, and this answer takes 5.1 squared and returns that. Now, it is not necessary to only have one parameter. In fact, we have already seen functions which have several parameters. After all, there is printf. Right. Well, that's it for this module.